Hey guys, welcome back to another video. In today's video, I'm going to be covering the chain rule. So let's begin. The chain rule is used when you have a composition of functions, or where you have one function inside of another. So let's say y is equal to f of g of x, or that is equal to f of u, where u is a function of x. Well, the derivative of y, or this, is equal to f prime of g of x multiplied by g prime of x. Or for f of u, the derivative of f of u is f prime of u is equal to f prime u times u prime. So you can notice there's some sort of pattern. You take the derivative of the outside, keep the inside the same, and multiply by the derivative of the inside. So in word form, we differentiate the outside function while keeping the inside function the same, and then we multiply by the derivative of the inside. So this is what we did right here. And the chain rule can also be written in Leibniz notation, and basically it's just the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. So essentially, the derivative of y with respect to x, so you have some function f of u, well, that's equal to the derivative of f of u times the derivative of u with respect to x. Leibniz notation helps us visualize what is occurring within the chain rule. So let's let y equal to f of u and u equal to g of x. Then the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. So let's think of the dy term as being dependent on the du term, and the du term as being dependent on the dx term. So this notation essentially shows that the rate of change of y with respect to u multiplied by the rate of change of u with respect to x. So what I recommend for the chain rule is that you use the Leibniz notation to visualize what is happening and to see how each variable depends on the other, and use fu notation where y is equal to f of u and u is equal to g of x to help apply the derivative easier. So to do chain rule, you differentiate the outside function, keep the middle function unchanged, and then multiply by the inside derivative. So if you're using this notation, make sure to substitute back in g of x for u at the end to express your final answer in terms of x, and to make sure to check your work to make sure that everything's fine and accurate. Okay, so the chain rule can be done with multiple compositions. So let's say y is equal to f of g of h of x. This can be rewritten, well, the derivative could be f prime of g of h of x multiplied by g prime of h of x multiplied by h prime of x. Or in Leibniz notation, the derivative of y with respect to x is equal to the derivative of y with respect to u multiplied by the derivative of u with respect to v multiplied by the derivative of v with respect to x, where y is equal to f of u of v of x, where u is equal to g of h of x, where v is equal to h of x. So now let's do some practice problems. So this one is really simple. We can use, let's say that u is equal to x squared plus 1, and that f of x, or f of u, is equal to u squared. So we can do power rule, and we can take down the degree and say that now we have 2 times x squared plus 1 to the power of 1. But in chain rule, you multiply by the derivative of the inside. So the inside derivative is just the derivative of x squared plus 1, or just 2x. So we will have that our final answer is 4x x squared plus 1, or 4x cubed plus 4x. Okay, so now let's move on to the next question. We're looking for the derivative of sine of x squared. So let's say that f of u is equal to sine of u, and that u is equal to x squared. So the derivative of this, f prime of u, will be equal to cosine u multiplied by u prime. So we know that u is equal to x squared, so you have cosine x squared. The derivative of u, or u prime, is equal to 2x. So we can say that the final derivative will be equal to 2x cosine x squared. Okay, so now this is where things get a bit more trickier. So for this one, we can rewrite the function to say that this is sine x squared, because these are essentially equivalent, plus x squared minus 1 to the power negative 3. Like the first one, we do power rule again, so we can say that the derivative of y is equal to 2 sine x to the power 1. So on the outside you do power rule, we have to multiply by the derivative of the inside, which is cosine x, because the derivative of sine x is cosine x, and then you add the derivative of this term. So we're going to take down the power of negative 3, so negative 3 x squared minus 1 to the power of negative 4, subtract 1, and then we multiply by the derivative of the inside, so now we have 2x. So once we simplify, we have that y prime is equal to 2 sine x cosine x minus 6x over x squared minus 1 to the power of 4. This could also be written as sine 2x, so and it'll still be the same thing, because this is a trig identity. Okay, so now let's find the derivative of y is equal to 1 over 5x minus 6 squared. So what we can do is rewrite it to say that this is the y is equal to 5x minus 6 to the power of negative 2, because this is the same thing as this, because as you can see there's a 1 right here, but if you were to put negative 2, that would give you the same result as before. So now this is an easier way to do it without needing to do quotient rule. So to find the derivative, or y prime, you take down the degree, keep the inside the same, subtract 1, then you multiply by the derivative of the inside, which is 5, and now you have that the derivative of y is negative 10 over 5x minus 6 cubed. Okay, so now we're going to find this derivative. So if you haven't memorized the trigonometric derivatives yet, you can do the pst method, where you say the word pst and each letter corresponds to a trigonometric function, and then below that you write the coangle, but for the second cosecant you write a negative. So we're looking for the derivative of secant, which will be secant tangent. So we can say that y prime is equal to secant 2x tangent 2x. Okay, but now we're going to multiply by 2, because that's in the inside of secant 2x. So let's simplify this part for now. Secant 2x tangent 2x. So now we're going to find this other part. So this term can be rewritten as sine x to the power negative 1. So now we can say that this is 5. Derivative of sine is cosine x minus 1. Then we take the derivative of x, so now you have negative 1 x to the power negative 2. And this will simplify to, negative 5 cosine 1 over x squared. And that will be your final answer, which is 2 secant 2x times tan 2x minus 5 cosine 1 over x squared. Okay, so now we're going to find this derivative. So we do the same thing as the other ones. We take the derivative of the outside, keep the inside the same, cosine sine x. Then we multiply by the derivative of the inside. So this is now the new inside. So the derivative of cosine is negative sine. So now we're going to keep this inside the same, sine x. And now we're going to take the derivative of this inside, which is cosine x. So this will simplify to y prime is equal to negative cosine sine x times sine x times cosine x. And that will be your final answer. Okay, so now we're going to find this derivative. So what we can do is we can rewrite it again. So you have 2x all to the power of 1/2. So we do the same thing for the other ones. We take the power rule. So now we have this. We keep the inside the same. And now we multiply by the derivative of the inside. So this is just quotient rule. So we can do quotient rule over here minus, oh sorry, multiplied by 2x. So this is the bottom and this is the top. So the top goes right, the bottom goes right here. Then we take the derivative of the top. Then we subtract the top multiplied by the derivative of the bottom, which should be 2, all divided by 2x minus 5 squared. So this seems a bit messy so far. So I'm going to go simplify it. Okay, so let's say that this term, so as you can see, this is negative 1. So this will be flipped. So you have 2x to the power of 1/2. And over here, x squared to the power of 1/2 would just be x. So now you have 2x multiplied by 2x minus 5, 2x, negative 2x squared over 2x minus 5, 4 over 2. So the reason why I wrote 4 over 2 is because there's a common factor over here. So we can cancel one of these halves out. So this goes down, and this goes down to 3. So now we have y prime is equal to, let's see, let's multiply this in. So we have 4x squared minus 10x minus 2x squared is equal to 2x minus 5 to the power of 3 over 2. We can simplify this even further and say this is 2x minus 10x over 2x minus 5, 3 over 2. But as you can see here, they have a 2 and an x in common, so we can factor out a 2. So now we have x minus 5 over 2x minus 5, 3 over 2, and that would be our final answer. So we got rid of a 2x because this has a 2x in here. So when you cancel this out, you're left with x, and negative 10x is the same thing as negative 5 times 2x. So you can also cancel out a 2x from here. So you'll be left with x minus 5 over 2x minus 5 to the power of 3 over 2 as our final answer. Okay, so now we're going to do this derivative. So we're going to find the derivative of sine of tangent squared of cosine x squared. So let's start off with the derivative of sine, which is cosine. Keep the inside the same. But over here, instead of tan squared x, I'm going to put tangent cosine x squared over here. So basically, tangent is still being squared, but I just put it out here because it will make our next step easier. Because now we have this inside, which is comprised of the power of 2 and tangent. So we take down the degree, multiply by tangent cosine x squared, and now we're to the power of 1. So now we're going to take the derivative of the inside of tangent, and the derivative of tangent is secant times secant, also known as secant squared cosine x squared. We keep the inside the same, but now we have to multiply by the derivative of the inside. So that's negative sine x squared. But now we take the derivative of this inside, and now we have 2x. So let's go and simplify this. There's a negative and a 2 and a 2x right here. So we're going to start off with y prime is equal to negative 4x sine x squared. Let's see, now we have, okay, now we multiply by cosine tangent squared. Let's say this is cosine x squared multiplied by tangent cosine x squared multiplied by secant squared cosine x squared, and that would be our final answer. I know it seems a bit long, but that's just how it is sometimes. But yeah, that's the answer to this problem. Okay, so now let's move to this one. This is just quotient rule with chain rule included. So we take the bottom, low d high minus high d low over low low. Our low is going to be equal to tan, or our high is going to be equal to x squared minus 1 squared. So let's put our low over here. Put the derivative of the high, which is 2x squared minus 1 power 1 times 2x, because this is the derivative of the inside. Subtract x squared minus 1 squared secant squared x, because that's the derivative of tangent. As you can see here, secant, all over tangent squared x. So this is a pretty long equation, but it could be simplified. So we are going to. So now we have, let's put this over here. Now we have 4x, x squared minus 1, tangent x, minus secant squared x, x squared minus 1 squared, all over tangent squared x. As you can see over here, there's common x squared minus 1 terms that we can get rid of, or factor out, sorry. So we can say that y prime is equal to x squared minus 1 multiplied by 4x tangent x minus secant squared x multiplied by x squared minus 1 all over tangent squared x. Well, usually in these problems you can factor out one part of the denominator. So let's find secant squared x in terms of tangent x. So secant x is 1 over cosine x, while tangent is sine x over cosine x. So if we were to divide by tangent, we would get 1 over cosine x multiplied by cosine x over sine x. As you can see over here, we would be left with cosecant x. So if we were to divide by a tangent, we would be left with cosecant x multiplied by secant x, because we only got rid of one secant and not both of them. So we can rewrite this to be x squared minus 1 multiplied by 4x minus cosecant x secant x multiplied by x squared minus 1 all over tangent x. And that will be our final answer. So now we are required to find the second derivative of this function. So let's start. So we have y prime. So we're going to start with the power rule. We take down the degree, 3 over 6, 6 minus 7x squared. Then we multiply by the derivative of the inside, which would be negative 7. And then we're going to add by the next term. The derivative of tangent will be secant squared, based on this, cosecant, negative cosecant, cotangent. So this is tangent, and it's a secant, so it would be secant squared x cubed. Derivative of x cubed would be 3x squared minus 8x. And once we simplify, we would get y prime is equal to 1/2, negative 7 over 2, because there's negative 7 over here. 6 minus 7x squared plus 3x squared secant squared x cubed minus 8x. So now we're going to find the second derivative. So y prime prime, we just do the same thing as the first time. We take down the degree, so negative 7, 6 minus 7x to the power 1 times negative 7. This will make it become positive. And then we add, but as you can see, there's a product of two functions. So what we're going to do is product rule. So f of x times g prime of x plus f prime of x multiplied by g of x. And that would be the derivative of this term. So let's start with 3x squared multiplied by the derivative of secant squared x cubed. So we can rewrite this to say that this is the secant x cubed but squared, because that would be the same thing. So we can use power rule to simplify this. So we can say 2 secant x cubed to the power 1, and now we multiply by the derivative of secant, which would be secant tangent. So now we have secant x cubed tangent x cubed multiplied by the derivative of the angle. So now we have 3x squared. So this will be our first term, but I'm kind of running out of room, so we're going to add the second term, which is a lot simpler than the first term, which would be secant squared x cubed multiplied by the derivative of 3x squared, which would be 6x. So once we simplify this, we should get that 49 6 minus x plus, let's see, we have a 9 over here, an x to the power of 4, and 9 times 2 will be equal to 18. So you have 18 x to the power of 4 of secant x cubed multiplied by secant x cubed. So we have secant squared x cubed tangent cubed, x cubed, sorry. And then we add on the last term, which is 6x secant squared x cubed. I forgot about the negative 8 over here, so we can just put negative 8, because the derivative of negative 8x is negative 8. But since I ran out of room, I didn't notice it. You should put it over here. Subtract 8. And if you can notice, there's common terms over here. So we can factor out a secant squared from there. So you have 49 times 6 minus 7x plus, but there's also a 6x term that's common for all of them. So we can say that this is 6x secant squared x cubed multiplied by 3x squared tangent x cubed plus 1, and we subtract 8. This should be cubed, sorry. So 3x cubed tangent x cubed plus 1 minus 8, and that should be our final answer. Okay, so this is the last problem. It might seem a bit intimidating at first, but if you can notice that this is just a power raised to another power. So you can rewrite this to say y is equal to the cotangent of x minus 2 over x squared to the power of 6 minus x plus 1. So now this derivative has become a lot simpler. I mean the function, but well, the derivative as well. So now we have y prime. So we need the derivative of cotangent. So let's find it. So cotangent has negative cosecant and cosecant. So y prime is negative cosecant squared x minus 2 over x squared to the power of 6. And then we multiply by the derivative of the inside, which is just this term to the power of 6. So we're going to take down the degree, x minus 2 x squared to the power of 5. And now we're going to take the derivative of the inside, which is going to involve quotient rule. So you have x squared times the derivative of the top, 1, minus x minus 2 times the derivative of the bottom, which is 2x, all over x to the power of 4. So before we do anything, we should simplify this part over here. So we're going to find that this is equal to x squared minus, let's see, 2x squared minus 4x, all over x to the power of 4. This will simplify to, let's see, negative x squared minus 4x, but it's still x power within here. Also, this should be positive, sorry, because negative times a negative is positive. So you cancel out an x, so that's going to equal to 4 minus x over x cubed. So now we can rewrite our derivative to say that 6 goes over here, so you have negative 6 cosecant squared x minus 2 x squared to the power of 6 multiplied by x minus 2 over x squared to the power of 5 multiplied by 4 minus x over x cubed minus 1, because there's this minus x over here. Essentially, because we have a negative x over here, the derivative of negative x will be negative 1. So you just add on the negative 1 to the end, and that will be our final answer. So I'm going to add this to the other terms. That's the derivative. Thank you for watching, and stay tuned for more videos.